Did you have to upgrade the electrical at all for this, or is it just like
Well, the shop
240?
didn't have any real electrical.
So you had to install electrical for this?
Yeah, this isn't too crazy. This is only, like, I think it's only 20 amp on,
Oh, really?
and it's
240?
actually it's only 15 amp on 240.
Huh.
So it's not anything nuts.
That's
Which
less-
is why they're great for like garages.
Yeah, that's
and
less
stuff.
than I thought.
I need to open the
Oh,
file.
I even have a folder on here.
Yeah. There we go.
Nice.
So we'll load this program. Everything should work. I mean, I tested it all, but this is machining, so maybe I messed something up. What's really cool about like these modern machines is like you can actually see the tool paths, and you can position like the tool where it needs to go, and you'll actually see the tool on the screen, and you won't like mess up and smash into your vise like most people will do the first time.
You hopefully won't.
Yeah. So I got some stock, and we need to cut 45 millimeters off that. You know, you need to make it as big as the material you need, and you always want to kind of stay in that area so you're not wasting material.
But when you're starting out, you're probably going to waste a lot of material.
Yeah. You're going to waste a lot of stuff. Tools, maybe. Tooling.
Hopefully not in your most expensive bits.
So we got our piece of stock.
Nice.
And I just like to knock the edges off so that you know when you're clamping it.
So you don't slice your hand open?
That too, but if you're clamping it, you want to make sure you're not clamping into like, it's going to tweak your workpiece.
Yep.
Guess we should get our safety glasses on now that we've done some work. Let's see here.
Always a good idea.
All right, so we're going to position this. I've already got a located position on this for the vise, because we can, so the vise is rigid and this back piece is rigid. So that means I know that this corner, and I've added this piece, I know the location of this corner because I've probed it already.
So you don't have to
Yeah, so we don't have to probe it today. Also, all the tooling for this like process is already in the machine.
Otherwise, you'd have to set things up.
Yeah, so you'd have to set up each tool and like how far down the like where the tool starts. You have to probe that. That's what that does.
Can it do that automatically if you say like, here's my tools? And
yeah, you put in the tool and then you say basically test the Z height on this, and it will just touch the tool to that.
Is that like a $5,000 add-on for this machine, or is it
this thing
standard with these?
For the Tormach version, it's like under 1,000, I think. But that's my version, which is $50.
Is it about as accurate as theirs, or is there any big difference?
So the thing is, it's pretty accurate because you can, it's just interrupting a signal.
Yeah.
So it's like, once you know that height, it's pretty repeatable. But obviously it's not going to be anywhere near like...
It seems like that's something that it's unintuitive to me, because I'm always thinking about new technology being so much better, but it's like a lot of times you just have a reference, and as long as you use that reference, then you can do things that are extremely accurate compared to what I would think you could do.
And it's also about like repeatability. And you know, if you're manual in machining, you can just check things over and over. And you can also be really accurate. Just like how easy you're making your life.
Yep.
So right now we're setting this, and we're actually going to cut the material out of this top piece. So what I can do is I can load in the first, like I don't need to do this, but I can load in the first tool, and then I can bring it down and just make sure that like the Z height and everything is correct. So bring the tool in. It's going to ask you, do I want to fetch it? Yeah. So the first time, it's just going to home all the tooling. So that's the first tool we're going to use. Which is
M.O.R.E can't do that.
I don't think so. I think they do have tool changers, maybe.
For the Carrera, whatever the main one is.
Oh, the car, yeah.
Not for the Z1 for sure. And it doesn't make any cool sounds like that either.
Yeah. And we also may not get a great view because we're going to be spraying coolant everywhere, which I don't think the M.O.R.E does either. So we can bring this close and then you can start to see it on here.
Mm-hmm.
And yeah.
That's cool.
So, and you can see some of the patterns. You can see even the, like the arrow and things in here. This is where the tool paths are going to go. So once we start this, the machine's just going to do its thing. It's going to run through the G code, which tells the machine where to go, what tools to fetch, do all that stuff. It's pretty well optimized, but you know, things like the drilling and stuff are still kind of loud. It'll work, and we'll have a half of a part when we're done. All right, so I guess we'll see if something happens or if I forgot a step. But yeah, we'll go for it. So basically, in any procedure, you need to take off like the rough material, and that'll just give you a really accurate.
Nice and flat.
Yeah, you'll get a good reference because you know where the bottom of the tool actually is.
Yep.
Versus so like, you know, your stock could vary a few millimeters even, and once you plane it off, then you know exactly where the top of the stock is.
So it seems like a waste a lot of times when you see somebody cutting off the top of something, but it's like, if you don't do that, you're not going to have your perfect flat.
Well, the great thing about machining metal is that like almost all metal is recycled, right? So it's like, oh, so right now the program is told to stop between each tool change, and that's just like kind of a
to make sure it's not just doing nothing in the air.
But what I can do is I can turn that off because I've run this before. So and I can just explain what's doing each time. So this is just drilling a spot drill, which is like a more rigid regular drill. And that lets you start the hole before you put the actual drill into it.
So you don't have to mess up your more precise bit?
Because the other drill's long. So once you touch into the tool, it could walk millimeters even, and then you're off. This drilling's a bit aggressive, so I'm gonna turn it down a little bit. It's not too bad. And the nice thing is when you're like drilling is a pretty quick way to like remove material, and then you can, you know, if you have a hole and you need to mill it out, it's nicer on your end mill to not have material in the very middle. Yeah. Because the very middle of an end mill is barely spinning. Right? So it's almost not moving at all the closer you get to the machine. So you don't really want any material in that middle.
So you drill a hole and then you clean up the hole.
Yes. So this is going to do the outside profile. This is a 2-flute end mill, which is good for aluminum. You'll probably do a lot of reading about feeds and speeds, but maybe M.O.R.E has like things for their tooling already that they know. Yeah. Because there's so many different things, like how deep of a cut, how fast you spin the tool, and how quickly you move that tool into the material.
Yeah.
And obviously there's calculators for all this stuff now.
And some of it too, I presume, is like after you do some, you're like, yeah, you know what, take off 5% on that or whatever.
Yeah, you know, a lot of it by ear and like that. But a lot of machining is like optimizing, which is something I don't necessarily have to do because I'm not machining hundreds of parts a day.
Yep.
But it's still fun to do.
And if you're doing factory parts and you want to turn out 5% more per day or whatever, then you start optimizing the little things.
And they will measure tool life to the minute, right?
Yeah.
Because it comes down to every dollar and cent.
It's funny on the Z1, I know it just does air. I'm presuming that for cutting something like this, you'd want to probably do it even slower to make sure things don't heat up, or would it need to even pause?
Like in terms of keeping the part cool, or like the tooling?
In terms of keeping the tooling cool enough to not break or get brittle or whatever?
Yeah, so a lot of the time, so cooling is part of it, but also chip clearing is a big deal. So the air, if you've got enough chip clearing, like with aluminum, you can get away with a lot. But yeah, I guess that would also be accounted for in their feeds and speeds. So.
Yeah.
But this should totally be doable on the Make.Era.
Yeah.
It definitely won't sound as fun. It'll be a lot higher pitch for some things. So those were just roughing passes, and then I do a quick, you heard it speed up a little, now it's doing like a bit of a finishing pass. Because I had a few minutes to try and make the part look a little bit nicer. And also the first time you start machining, you're going to be hovering over the E-stop button or the stop button, just like, I look more relaxed than if I was doing something I hadn't done before.
I remember the first few 3D prints, you're sitting there watching like every little bit of the layer line, especially back in the earliest 3D printers without the bed leveling.
Well, that was like the meme, right? Like start a print without waiting for the first layer or something?
Yep. Except with machining, every single little thing that you do is like, yep, that just broke. Have you had a part where you spent hours and hours and then you just totally screwed up with one pass on something?
Not hours. I do have some broken parts here, but these are just too aggressive cuts. So I was trying to machine something that was already really thin walled, and then I was trying to surface this, and it just knocked the part off, and it just flew off in the machine. So I haven't done anything super complicated yet. So we're doing another tool change. This time it's a smaller end mill. This is for the little holes that we drilled.
Yeah.
It's just gonna open them up like maybe 0.5 millimeter because of the design. So I drilled a 4 millimeter, and these are just slightly bigger.
One thing I still don't understand is how they can be so good with threading that you can do threads with a
single point
mill. Yeah, it's like after tapping things before, it's like, how does the machine do that so precisely?
And the other cool thing is when you're machining, like using a CNC, is you can chamfer all the intricate edges. You can't do that on like a manual machine part.
Yeah.
If you watch like Inheritance machining stuff, like he chamfers things that the average person can't on his manual machine because
that requires a deeper level of skill.
Yeah.
That a computer can have.
Rotary tools, and that just adds that extra layer to like the finished look.
Right. How much more time is left on this part?
It says 8 seconds, but I think because I had it paused at the beginning, we're an extra 15 or something. That was the noise people were talking about.
Here. It's kind of a sci-fi sound.
Yeah, it's got 2 more processes. This one's quick.
My battery is just about dead. That's
Oh, okay.
and it stops.
Is it the same as mine?
It should be. It's the whatever
Yeah.
the Sony standard is. What is the part that it's doing right now?
It's doing a little tiny.
Oh, is that the arrow?
Yes.
It's cutting out the tiny arrow.
It's a super tiny arrow right here.
Yep.
So the smaller the, the bit, the more careful you have to be with each pass.
You can't go fast, otherwise it'll snap.
So when I did the tokens, like the little coins that I sold, like the face took forever because I wanted a nice detail, but like it can only take off so much
Because
material.
it has to go up and down and do all that stuff too.
Yeah. Oh, wait, this is the chamfer.
Oh, okay. Yeah, I was gonna say, like, it looks like it just went right into that.
I forgot that I put in a smaller chamfer tool to get a nicer chamfer, so.
Only the best.
So the other one I had was too wide, so it wasn't able to go into the corners more.
Yeah. And do you need the air compressor to? What is it powering?
Just to change the tools.
Oh, that's all it's used for. Okay.
Yeah.
Huh. I thought it like gave pressure for the coolant, but it's like no, you'd have a pump for that.
Yeah. So there's a big tank under here.
Yep.
All the chips go down there, and you can pull that out and get all the chips out of it.
Yeah.
Sometimes speeding up a process means just getting rid of these really, really slow plunges down. It was like 10 seconds.
Yeah.
But it's just because it's like you've set a value that is like part clearance, and it's just being careful.
Yeah.
Most of those I've taken out and made them a lot smaller, but that's it. That's one side.
Nice.
We'll dry it off. You can have the part in there. It's one half of the finished part.
Already looks beautiful.
Grab
Especially
it
compared to the ASA print. I've never gotten ASA to look as nice as PLA coming off the bed. There's always a little raised corner edge or whatever.
So now we're going to flip it over this way, and we're going to take the rest of this material off. And we're going to get that little
Except
bump
for the
that you
little
hate.
bump, yeah. The bump that's, I'm sure some Apple engineer's like, yeah, just put a bump there. It's like, do you realize that that adds like whatever amount of extra time and
Doubles the whole process.
effort instead of just making it flat?
So same thing, but I'm just butting it up against this. And you have to make sure everything is nice and flat with these parallels. But the worst case scenario is if it's not flat, because we're taking off material, you're just going to have a...
Slightly skew.
Yes. In this case, it doesn't matter, but in, a jet engine, it might.
That might be life or death.
And I've already referenced this, so we're going to load the new program. So there's a little bump, a little 0.5 millimeter bump, I think it is, and a couple of holes drilled.
Yep.
Just double check that I tighten that.
Are the lights on top things you added?
No, those are in there. They came with them.
Okay.
They're nice and bright.
Because you need light for the work, but it's also like if you're doing YouTube, you want better lighting for actual video too.
Yeah, and you can get these windows that
Yeah,
rotate really fast.
I've seen those. Yeah.
There was one on this,
Yeah.
but it's gone now.
I see the circle there. You need to make a lens cap that spins.
Yeah.
The filter.
These actually have a webcam plugin where you can monitor it on the online.
With a spinning filter on it?
No.
Oh, well that stinks.
Okay, we've loaded it. We should be all aligned. We'll hit go and see what happens. I'd say most I'll wait for that. I'd say most crashes probably happen within like the very first cut because someone has set an incorrect home location or like part location basically.
Or they didn't rehome after putting a new tool in or something.
Yeah, or they didn't realize. So like usually use like G54 or G50 location, and say it's like it thinks it's below the table, then it's just gonna go. Phoom.
So the first time, do you actually just do it?
So the important thing, and everyone does this, is you air cut your very first thing, and you basically set your home location, and you go, yeah, I'm gonna do 20 or 30 millimeters higher, and we're gonna pretend that the part is 30 millimeters higher.
Yep.
Cut that. If everything looks good, then lower it back down to 30 millimeters.
Yep. Are you holding the doors because they fly open sometimes and shoot stuff out at you?
No, but I like how this says replace windows every 2 years.
Oh.
I don't think that's been done. And there's no date, so.
Well, there you go. Then as long as you don't put it on there, you don't have to worry. There's an E-stop, but what's the blue light for? Does that reboot everything?
That is, yeah, after you've stopped, it turns all the motors off immediately.
Oh, okay.
That just turns the motors back on. Sends a little pulse.
Yeah.
Pulse through them. And I actually have a 4th axis for this machine.
Huh.
Haven't used it yet, but...
It makes your brain hurt.
Yeah, a little bit. And also Fusion, you have to pay more. And I'm really annoyed about that.
I did not realize that.
Yeah.
Does the standard license cover machining stuff?
Yes.
Okay, good.
Yeah.
Because I don't want to pay more than $600 a year or whatever it is.
I know.
That's one of the other reasons I kind of want to learn different software. Is like I don't like using things that I can't say. And you can do this too. It's like
I know.
You can pay $600 and do this too.
That's why it was nice when they had like the more usable hobby-free thing. You'd be like, go and use Fusion. I'm using it. You can use it too, as long as you're not using it for your business.
Yeah.
Now it's like, no one. Oh, you want to save a file in a certain format? We took that away.
Yeah.
So again, we're just drilling holes. Just one hole.
That's for the magnet.
Is there a magnet?
Yeah.
Okay, so that one needs to be kind of precise then?
Yeah.
Or you can glue it in?
I mean, yeah, I think that they're glued in production too. But it has a magnet that it just holds it on the rack while you're getting your screws ready.
Oh, okay.
It's kind of nice, but it's also kind of stupid.
I also realized I've had the feed down this whole time.
Oh.
So that's why it took
slower.
that extra minute.
Yeah.
Yeah, so if it was press fit, then we'd have to be more serious about that.
Yeah.
That whole size.
I don't think that the ones at Apple, it looks like they were glued in. Yeah. They're not perfect.
Oh, okay.
You know? It'd be funny if after I make this video, some Apple guy is like, yeah, we actually CNC'd all those by hand because we only made like 12,000 of them. And
so right now you can see we're like, a millimeter or so above the vise. Kind of hard to see, but it's very low clearance because it's such a small part. You need the ability to clamp onto the part, but you also need to cut away the stuff. So in this case, the part's only like 4 millimeters.
Have you ever cut your tools?
The vise? I haven't really. Nothing serious, but like some scenarios where you might just graze it.
But you do have like sacrificial things sometimes to hold something.
Yeah, so and you can glue parts down. There's all different ways to do it.
Yeah. Yeah, the M.O.R.E has a vacuum bed too for thin stuff.
Oh, that's nice.
Which I was surprised that they'd have that in like the cheapest model.
Yeah. There's a neat thing that there's some vacuum tables you can like make vacuum tables out of like MDF or like LDF, and it actually just pulls vacuum through the material itself.
Yeah.
You don't need to drill any holes.
Because it's so porous
enough.
Yeah. This battery's gonna die soon too.
How much longer you got?
Any minute now. It's doing the little battery indicator, so who knows? Ah, I was trying to get focus on there before it went up. I like the little green light on that. That's fancy. The
Oh yeah.
blinks and stuff. Turns red if it explodes.
Usually they have the tower. I think this is their solution to the little light
Yeah.
tower. You can see it's moving a little bit faster now. We've ramped it back up.
Mm-hmm.
And then one last chamfer.
Making it all fancy.
Yeah, you just have to sell them at like $40 each.
Have you pulled a Matthias Swandell and made like an entire piece of furniture for your house yet?
No.
You watch his channel much?
Yeah, I do. Newfoundland or something. He's far, I think, now.
Okay,
Not sure.
so he's closer to the coast.
Yeah. All right, that's it.
Yay.
Got both sides.
Looks shiny. Whoa.
Lose it in the pit. Clean it off a little. Well, there's some things I'd still change on it, but got a part. And the little nub
Yeah.
that makes 3D printing really difficult.
So I have a few questions. One is, you mentioned a few things about like adjusting your speeds and things. I'll be doing this the first time. I'm not going to start with this. I'm going to start with their little sample project. But is that something that like the software can do it for you and then you tweak it? Or do you have to know a little bit about the bits that you're using and
I think,
all that?
yeah, I think so it depends on, so you're going to use Fusion, right?
Well, I modeled it in Fusion, but they have their software.
They have their own
too.
CAM software?
It's something like that, yeah.
So they probably have speeds and feeds for their bits because they sell bits with their machine.
Yeah.
And they're probably going to be like the best bet. Fusion thinks you have the best machine in the whole world. If you put anything in by default, it'll run this thing, it'll break everything immediately. Yeah, so I think they'll probably have that set up and ready to just get going, especially on their example stuff.
Yeah. Do you think that the first time I try making one of these, I will accomplish that task, or do you think I'll have a little failure first?
I think if you follow like the steps and you're careful and you use their feeds and things like that, you could probably do one first try if you know what you're doing. But there's a really good chance you won't.
Yep. What do you think is the most important thing for somebody that's new to machining anything to work on or think about or remember?
I don't know what the most important thing is, but if you're machining something new or you're just getting into it, definitely, like I said, being really conservative on the speeds and like feeds and things like that. I guess accepting that you're gonna break bits and you have a lot. The funny thing with machining is any machine you buy, it's like, oh yeah, I bought the machine, now you have to pay the same amount for all the tools you need. So like, you have to keep that in mind anytime you're looking to get something, but obviously that's not like a hard and set rule. But something like this, you're gonna end up spending money on the tools and you have to be willing to break them.
Yep. And you don't learn unless you break some things.
Yeah.
And
you always break things.
seems like another hobby where humility is one of the required attributes.
Absolutely. But yeah, it's fun and it's totally becoming way more accessible to everyone. So
yeah.
I think that's
Have you used one of the desktop CNCs at all before? Like the
Like
Air
McCarran,
or any of them really? Because there's a couple other models I've seen that aren't McCarran.
So I've no desktop ones. I do have the Shape Boko XXL back there inside that wooden box.
Oh yeah.
And that does like wood and acrylic. You can do aluminum on it a bit, but nothing like modern like that. This thing is pretty much a desktop machine.
If your desktop can support the weight.
It's probably only like 400 pounds.
I guess this is an interesting question from a guy who got into 3D printing when it wasn't like cutting edge, but it wasn't quite what it is today. I learned a lot about 3D printing before I got a 3D printer that does most things for you. Is there any value of learning, especially like if you want to get into it, is there any value of learning machining on a machine like this before you get into computer control and AI? And
yeah, that's like a really good question, because like maybe not, because if you just get like a make error or something like that, then you can totally just get right into it. And manual machining is wildly different, because you can feel the machine, you can do all these things. You actually can't really translate that to a CNC machine. You can't feel it. You can maybe hear it, but like it's gonna move when you tell it to move. It's not like you can just feed into it. I think like the art of manual machining and CNC machining are kind of their own thing, and you're gonna learn no matter what. So even if you like try and learn manual machining, you're gonna spend probably the same amount of time just getting into CNC.
So it sounds like in some ways it's kind of like with photography. Like I have my film camera, and it's photography still, but it's a different thing. And it's like some of the skills might transfer, some of the knowledge, but it's not the same thing. And you might or might not ever even get into it.
Yeah, and that's kind of one of the crazy things I think about when I've bought old CNC machines, all this stuff, and they're coming out with this new technology. These guys have been machinists probably for 40 years, and they're thrown into this computer world, and the computer guys don't know how to machine things, but the machinists do, but they don't know how to use the computers. So it was kind of a different world, because they were coming from manual machining and learning computers like on the fly. And I think that's one of the coolest things, is that like these old school guys are learning CNC. It was just like a whole other world of like incorporating something that didn't ever exist. But I don't know where I was going with that, but it's just a cool thing to think about.
Yeah, no, it's a lot of industries seem to have the same kind of thing, broadcast engineering, and the guys who evolved with it versus the guys who retired out and were like, good riddance.
Oh, totally. It's like there's a lot of lost art going on. And yeah, like the one machine I had, it's not here anymore, but like they would just type in the G code, and it would do everything manually. They do arcs, they do all these things by hand, type it in, and then let the machine do its thing. Like I couldn't even imagine that.
Yeah.
I'm Sean Hodgins, that's my channel. And whenever I do release things, you'll usually see some type of machine or 3D printing or electronics, and I've got a crazy shop, and we just filmed a cool thing upstairs in the electronics part. But yeah, that's where you'll find me. Yeah, so this was one of my projects. It was a fun little thing on my channel. I don't really know what to call it. But I sold these. I made a whole bunch of them, and yeah, they're just a little token that I made just to show what the machine can do. And this is out of brass. So brass is pretty much the easiest material you can machine, and I would recommend starting with brass as well. And this was, I can't remember if this is the one I used, but these are some soft jaws. These go in the vise, and these can hold that, and then I can clamp it. So that's after the first step.
So you made that tool on the CNC to hold these to make on the CNC.
Absolutely. And it was out of hex bar, and I cut a whole bunch of these on my lathe, and they started here. Cut the one side, and then I would flip them over, and it would cut the other side. And I did all this on a live stream as well, so it was pretty fun.
Oh,
yeah.
I'll be sure to link to that if I remember. And if I don't, somebody in the comments can tell me.